Hello Geotech Masters! Welcome back to our comprehensive tutorial series on the standard penetration test. I'm delighted to be your guide on this exciting journey into geotechnical engineering. We are moving on to the very heart of the standard penetration test, the split barrel sampler. This is the tool that directly interacts with the soil to give us those critical penetration resistance values and provides us with a soil sample for identification.
Have you ever wondered about the precise design of this sampler? What makes it standard? How does it manage to collect soil while measuring resistance? And why are certain dimensions and features so important for getting reliable results? We will answer all these questions and more in this video, so stay tuned. The split barrel sampler is truly the central component of the SPT. It's a precisely engineered device, designed to obtain a soil sample and measure the soil's resistance to penetration. The standard dimensions are very specific, and adhering to them is critical for the results to be considered part of the standard penetration test. Let's talk about these precise sampler dimensions first. The sampler has an outside diameter of 50 mm, or 2 inches. This is a fixed dimension. The interior is more complex. The inside diameter of the shoe, which is the very tip that first penetrates the soil, is 35 mm. Moving up into the main body of the split barrel, the inside diameter can be either 38 or 35 mm. This slight variation in internal diameter depends on whether the sampler is equipped with liners, which we'll discuss shortly. The length of the sampler is also important. It should be at least 0.6 meters. This specific length is necessary to accommodate the full test drive interval, which is 0.45 meters, plus an additional 0.15 meters, for collecting the soil material. This ensures that we have enough space to gather a representative sample for the entire test interval. As for its construction, the samplers are made from steel, and in most cases, they are hardened for durability. This hardening is crucial because the sampler is repeatedly driven into the ground, often encountering dense or coarse materials. So it needs to withstand significant impact and abrasion. The split barrel